The power of these truth tables really shows up when we evaluate more complex statements. So here, for example, we have the statement A or B and not C. Significantly more complicated statement than the ones we've seen in the past. It uses all three of our operators, and it has some parentheses to set off a certain portion of that expression. So this is a complicated statement, but the truth table allows us to organize the different possibilities and go through them one by one. Now this table is going to have 8 rows because there's 8 possible combinations of A, B, and C. They could all be true, they could all be false. Any pair of them could be false while the other is true, and any pair of them could be true while the other one is false. So here on the left, we're just defining all the possible combinations of those 3 variables. On the right, we want to evaluate that logical expression based on a certain combination of those 3 values. In our first row, all 3 values are true, and we notice that A precedes an OR operator. So whenever A is true, that means the entire statement is going to be true, because we only need one part of it to make the statement true. So A is true, B is true, and C is true. However, if C is true, that means that not C is false. And that means that B and not C is also false. It's not true that both B is true and C is not true. However, none of that matters because A is true, and our OR operator says that as long as A is true, then the entire statement is true. And so the result for that first line is true. And in fact, we can go ahead and generalize that. Because our statement starts with A or something else, then as long as A is true, then the result will be true. So we see that for all the rows that have a true value for A, our result is also true. So we can jump down to the bottom half instead. In the bottom half, A is always false. And so the only way for the statement to be true is if the second half of that OR is true. The OR is true if either the left or the right side is true. So if A is false, then the parentheses must be true for the statement to be true. As we noted before, if B and C are both true, then not C is false, which means B and not C is false. So if both are true, then our result is false. We might go ahead and notice also that if B is part of an AND operation, then this parentheses can only be true when B itself is true. So those rows where B is false, we can go ahead and rule out as false. The overall result is only false because A was also false. When B was false, but A was true, it was okay because the A as part of that OR operator rendered the entire statement true. So now we're just left with that one row where A is false, B is true, and C is false. If A is false and C is false and B is true, then not C becomes true as well because it alters the value of C. And so if both B and not C are both true, then that parentheses is true, that AND is true, and so our result is true. So this is a pretty complicated logical expression, but we can trace through it one row at a time. Or we can notice some patterns and go ahead and commit our results in big groups. We could notice, for example, that if A is part of the OR, then anytime A is true, the result is going to be true.